welcome everybody. This is the 25th of March, 2025, and this is Open Research Institute's meeting for our FPGA projects. And what we do is we talk about what we have done over the past week, what we have planned to do over the next week, if we have any roadblocks that we need help with, or if we need any resources to complete the open source digital radio work that we're doing. So I'd like to open the roundtable with Erin to tell us how it's going and what you need and if you have any issues.
Sure. Thanks, Michelle. So last week I didn't have much time to spare. I'm happy to report, though, that I received all the parts to build the British Amateur Television Club's Pico tuner. So I'm debating whether or not I'm going to create like a build video for it. So taking it from assembling the PCB all the way to the point where it's receiving DVB-S2 signal. In my research, I did find out, I guess I kind of knew this going into it, was that they replaced the FTDI chip that had a full high-speed interface with the Raspberry Pi Pico microcontroller that only has a full speed. So into this, I know it's not going to be able to receive as wide of a signal that we are planning on transmitting from the geostationary satellite. But one of my goals is to figure out what that upper limit is on this Pico tuner. And then once I get a proper receiver working, or a known receiver to work, start working the transmit side within OpenCPI. So that's my goal. And another thing that I'll be working on is that I didn't purchase the aluminum enclosure that it was designed to go into, and so I'm planning on designing a simple 3D printed case for it, and potentially contribute it back to that club. But that's what I'm working on, and that's what I'm going to be working on this coming week. And any resources I need is more time, but it's nothing you guys can help me with. That concludes my update for this week.
Yeah, all empathy about the time. No, it sounds like you have elite videos then. The sort of the 3D printing construction video would be fantastic, and I hope you do it. So please let us know so we can amplify your efforts in communication. So thank you. This is a fantastic forward progress. Very appreciated. Okay, so Paul and Matthew. Let's see. There's a traveling today, so should be listening. Okay, no particular updates. Well, I think that's probably lowballing because there's been lots that have gone on that you've helped with and advised, Matthew.
I have a couple minutes if we to talk if we wanted.
Oh yeah, sure. No, we have time. We have lots of updates on Opulent Voice, so please, you have the floor.
Oh, great, thanks. Yeah, I mean, like, I didn't get much done today or last 2, maybe 3 weeks, but I've been trying to chime in where I've been able, particularly, I think, in the last few days about the sync header and how that's working. And it seems like we've made some progress. But beyond that, then I'm just looking forward to adding some of the features we've talked about in the past. The lock detector, maybe another frequency detection component, and I think there's a third thing that escapes me at the moment. So, there's definitely some additional work in putting some more details in. We were talking about some of the preambles and the framing structure, so I think we need to kind of revisit that. I know there's been a lot of work done, but if there's anything that would be we want to adjust for this modem in particular. I mean, I think we want a hardware-based modem frame, is my opinion, but so I mean, there's some things around that we can discuss. Again, I mentioned the chat. I'm a hardware guide, so I'd be inclined to put more stuff in hardware. But I mean, I think the point I was discussing with Paul is, I think we just need to have a really good hardware software architecture or partitioning so that my goal is that to make this easily portable to other platforms, so we're not reliant and something in the zinc necessarily. We might want to be able to have an FPGA that's, an expensive one of the new Chinese ones, potentially that doesn't have an onboard processor. And so we might have a SOM or something else sitting next to it. So just the idea being in my mind that we want to make things partitioned well so that we can uh, port them to other platforms. And so we're not, like I said, reliant on the zinc. But that's just what's in my mind. We can certainly have more discussions about that. But in the near term is more for me just getting these some of these features in, especially the lock detector, and and then I think we are in the point where we're going to want to start working on the framing more and how that's going to be implemented in hardware. I think that's all I had, unless there's some other conversation that comes up.
Yeah, thanks. That's a ton. What we've been talking about over the past week. It's what's been happening on Opulent Voice is moving from getting the basics of the stabilized, synchronized digital signal using PRBS or pseudo-random binary sequences spewed out over the air, and finally seeing some really good traction there. So we're going to continue to try to quantify, qualify, document, figure out, all of the different loops and loop gains, and making sure that we got good understanding there. But seeing some really solid results from some torture tests over the air. Paul ran an experiment that was well over 2 days worth of uh, you know, up and running, um,
That does
working link, it's good news.
that does remind me. I do have a comment about this in that. Uh, so I mean, I think it became really clear, and maybe Paul has a different view, but that the frequency offsets were the primary culprit in the independent receive Pluto. And so then the question is, what is our acquisition range need to be? And so what does it need to be? And then how can we address that? If we widen loop bandwidths too much, we risk the F2 locking onto the lower frequency or vice versa. And then, it's hard to be moved on that. So, do we want to keep smaller loop bandwidths, but then have some other mechanism like a sweep or something else that would help us acquire over a larger range? So I think that's another open discussion and needing some thought as well as to the best way to approach that.
No, very well put. So for those listening along, what we're talking about is a minimum shift keying open source digital radio implementation. This is our native digital uplink for our satellite uh, design. So this is a frequency division multiple access uplink and a time division multiplexed downlink. The downlink uses DVB-S2, S2X. So it's packaging up all of these uplinks. Each channel in the uplink, each frequency division channel is our digital proposal, Opulent Voice. And so really neat, innovative proposal. We're getting some good success there. So we're making lots of strides forward on the uplink. And so each of these uplink channels that we're talking about are multiplexed together onto a one big pipe on the downlink. So that's the overall big picture of what we're trying to accomplish. And yes, so we're making lots of steps forward here. So that should, so when we talk about the two frequencies or latching onto the wrong frequency, minimum shift keying, this is a sort of like, it looks like binary FSK or frequency shift keying, so two different frequencies. They're specifically designed in order to be to have no gaps whatsoever, no discontinuities between the two frequencies. So it looks like a totally smooth transition from one frequency to another. So when you're receiving it and you're searching for these two frequencies and you're looking for them, if your loop bandwidth is too wide, if your filters are too wide, if your view or spotting scope, so to speak, is too wide, then you might latch onto the wrong one. We don't want to do that. We want to have a receiver that only looks for one or the other, that gets one of the other frequencies, gets synchronized very quickly. Speed of synchronization is a good thing. It leads you directly to being able to okay, go ahead, decode, demodulate, that sort of thing as quickly as possible. So what we'd like to do is be very cognizant of this. On the other hand, in order to get acquisition very, very quickly, sometimes these loop bandwidths or these filters need to be very wide. So what we may end up doing is having some sort of adaptive system where we have a very broad view of, because we may be operating in very high Doppler situations, and we find our signal and then later on, narrow it down and be very precise. So lots of work to be done here still. But what we've had over the past week is some significant successes, and I'll turn it over to Paul, who can walk us through what's been going on.
Okay, thank you, Michelle, and thank you, Matthew. I want to share. So what I'm going to show here first is the long test that Michelle mentioned. Here we go. I'm not going to explain every line like I did last time, but you can see on the fourth row where it says accumulators, and on the sixth row where it says NCO, that's numerically controlled oscillator, adjusts, you can see a periodic wiggle. And that is the daily temperature cycle in the remote lab. So you can see we've got just over 5 full days of continuous testing with 0 bit error rate, except for one little interruption there almost in the center. I'm not sure what that is, but basically it worked continuously for over 5 days and tracked frequency excursions due to temperature shifts. So that's good. This is with internal oscillators on the Pluto, not upgraded. These are the standard oscillators that come with the off-the-shelf version direct from Analog Devices. So that's pretty good. That's a milestone that I'm happy about hitting. The next thing of interest is, as Matthew and Michelle have already talked about, trying to get a handle on acquisition, which is the whole process of getting from no knowledge about the incoming signal to being able to get good data bits out. And the procedure that we have sketched out and implemented and done some testing on for the old 4-area FSK modulation was that each transmission started with a preamble, which is a very simple pattern that's easy to acquire. And then each frame also contains a synchronization word. And the combination of those synchronization words spaced 1 frame apart makes a pretty long sequence. So you can't really get a false hit on synchronization. At least it wouldn't last for more than a couple of frames in the worst case. So we need to be able to do that. And we need to be able to do some experiments with that. That's going to require changes to everything. The application code is going to need to be able to make transmissions and then pause and make another transmission and then pause repeatedly for us to gather some data on how well that works. We're going to have to transmit a preamble, transmit a sync word, and then repeatedly transmit the sync word over the sequence of many frames, and then systematically or without disruption anyway, turn off the signal, have the receiver go back into an idle state, and then repeat, rinse, repeat forever. For some weeks now, actually since nearly the beginning of the year, Matthew has had preamble capabilities built into the hardware, and we haven't really been in a position to do anything with them. And now we've started to experiment with them. And this is what the preamble looks like on the spectrum. I'm not entirely convinced that this is the right spectrum, but I don't know what the right spectrum is. So this may be a correct preamble coming out of the hardware. We did see one other spectrum from this where the center peak was missing and the side lobe peaks were a little bit higher. Only saw that once on the first try. I believe that's probably just another incidence of the unexplained behavior we've seen before, where the center is notched out of the overall waveform. We don't know what causes that yet. We need to find out. And this may be a clue that we can be able to do it with a preamble. But where that clue leads, I don't know yet. In the meantime, we've got this nice preamble that is acquirable. The receiver seems to be happy with it. And then when we switch from this into sending data, it does it doesn't lose track. It does give data out. But what we don't know yet, because we're not looking at a small enough time resolution, is whether it does that without missing any bits. Um, we can't really expect it to in general because we don't necessarily know in advance where the boundary is. That's part of what the sync word is for. Um, if we went from this preamble to a sync word and then immediately into some data, and we were able to receive the very first bit of that data reliably, then that would be huge. That's more or less a mandatory minimum capability to do any kind of a system that's not steady state transmitting all the time. So we need to make all the different changes in order to create that scenario. So the application software needs to change. I think we need additional help from the hardware to generate that sync word at the right moment and also to detect it on the fly as we're trying to receive, and then go into the streaming data scenario. So in order, before we can make giant strides forward on that, we need to agree on how that all is going to work. Is it going to work exactly like we had before in the 4FSK implementation, or are we going to make some changes to it? And this is the kind of stuff that Matthew was talking about. We need to discuss and get, if not nailed down, at least a working preliminary versions that we can start experimenting with. Looking forward to making that change. We still have some other things going on. You can see, could have seen on the original, on the graph that I showed, that we still have some clock domain synchronization problems to fix. Um, and there are some other things that need to get figured out. But that's pretty much where we're sitting, and hope to make another big step toward a real workable radio here soon.
This is great. So yeah, this is a big milestone, big step forward. We were going to take what we found out over the past week and put it right back under our fingers and keep going. Okay, so hey, Thomas, I think he's joined us. Is there? Just want to check and make sure. Is there any other comments about the Opulent Voice work for the week before we talk about Eve?
I don't have any.
Okay. Yeah, thank you so much for all of your work, you and Matthew and all the folks that have been working hard on it. Or as you can see, we've got some big successes here, and really look forward to having a really nice product and being able to share it with folks.